Gipsters will be able to solve basic rate problems using unit analysis. All right. So looking at this, it says to build a fence, Kevin needs 15 feet of lumber per foot of fence that he wants to build. To build a fence with 200 feet of lumber, how long will the fence need to be? So I always start with the answer sentence because I always think that's the most telling thing about a problem is what am I trying to figure out? So I'm actually going to come over here. And so I'm going to look at this. It says, how long will the fence be? The fence will be blank feet long. Now this is a little bit confusing here because now I'm going to go back and up and I'm going to look at my rate. And I have to be really careful about how I label my rate here. So I see that it's 15 feet per 1 foot. Okay, this is confusing. So I need to make sure that I label what these different feet are standing for. It's 15 feet of what? Yikes, 15 feet of lumber. So I'm going to 15 feet lumber for 15 feet fence, or for 1 foot fence. So sometimes when you have these ratios like this, you have to be absolutely clear in your units because these both are measured with feet, but one is feet of fence and one is feet of lumber. So we're going to write it the other way around. 1 foot of fence is worth 15, or takes 15 feet of lumber. So in our situation, we have 210 feet of lumber. So just again, be very clear. This is not 210 feet of fence. It's 210 feet of lumber. So this is a rate problem. So I see again that there's, actually we don't need to do it like that. Here, let's, no, okay, hold on. Let's just switch this up. We wrote them yesterday with the equal sign over here and the multiplication over here. So let's notice that that's going to be the same on all of yours. So let's go ahead and fix that on all of them today. I'm actually going to go ahead and do that now for all these ones on the teacher time. That way we just get used to setting them up all the same way. Sammy?
Can you repeat that?
What? I want to look at it like this just because it mirrors the y equals mx format that we've seen already. And that's where we're moving with this tomorrow, is going to be taking some of these rate situation type problems and writing them using this concept to write equations, y equals mx plus b. All right. So a biker cycles 50 miles in 12 hours. How far can he cycle in 3 hours? So starting here with my question, I want to answer that question. How far can he cycle? Well, he can cycle blank. What are my units on this one? How far? Distance would be measured in this particular case in miles. All right, so my given rate, what's my rate? This one's a little bit weird because it doesn't have like a for each or a per or any of those like key words here. So we have to read very carefully. What's our rate, Dahlia? So you're saying 12 hours. What can he do in 12 hours? What's the relationship with the other set of units? If he cycles 12 hours, what does it tell us that's going to happen in that 12 hours? Yeah, 50 miles. So this is kind of, we can think about in this particular case, or in most rate situations, is cause and effect. If one thing happens, then another thing will happen. And those are kind of our rates, cause and effect. And so it doesn't use any of those specific keywords, but we can definitely see that there's a cause, 12 miles of bicycling, and there's an effect, 50 miles covered. All right, so our rate here is 12 hours for 50 miles, or we can write it the other way around. 50 miles is 12 hours. What are we trying to find out more about? What cause or what situation are we going to use here? What are we trying to find out more about? What is the situation in this particular problem that we are trying to figure out more about? Giselle. Yeah, what happens in 3 hours? All right, so our situation that we're trying to figure out about is 3 hours. So again, we want to set this up. We start with the units of our answer. So we're starting over here with miles as the units of our answer. We want to match that. Which of these two rates am I going to use, number 1 or number 2? The way that I've written them. Don't look on your own paper, because you might have written them backwards. Number 1 or number 2, which one is going to match my units across the top? Good, you're showing me 2, so I'm going to plug in the 50 miles over 12 hours. And now I can see that my units are messed up in that I've got this extra set of hours down here. So I can plug in my situation, which is good because we wanted to find out something regarding that. My hours and my hours cancels out. That's my proof that this is set up correctly. So again, focus on the units to make sure that it's set up correctly. And now it's just kind of multiplication and division. For me, I see some factoring I can do here. I know this 12 is 4 times 3. That allows me to cross cancel that 3 with this 3. And gives me 50 over 4. That just makes this a little bit easier. And this is one that you have your calculators. You can use your calculators for today because I'm not focused in on that. But I'll do it really quickly. It's going to give me 2.5. So 12.5 miles. All right. So looking at this one, again, I'm going to start with the question. It says, how much would 3.5 pounds cost? So my answer sentence is, it would cost blank. What are my units? Kelsey? I want to know how much it would cost, so my units for my answer, cost is measured in dollars. So now I'm going to go back through and I'm going to look and find my rate. This one's a little bit more obvious. It's got that key word. However, they did have it split over the end of line. Creston, what's my rate here? Yep. Yep, $5 per pound. And so I'm going to write down $5 per 1 pound, or 1 pound for $5. And what is the situation that we're trying to find out about? Brandon. 3.5 pounds. So this is, again, a rate problem. And we're going to set this up, again, always starting with the units of our answer. Always focused in on units. So I know my dollars go up here. I need to match those dollars over here, so I'm going to use one of the two rates. That would be this one here, $5 for 1 pound. And I need to get rid of the extra pounds down here, so I'm going to use my 3.5 pounds. Pounds cancels out with pounds. That proves that our units are correct. We have only the dollars left over. And this looks like it's just a multiplication. 3.5 times 5. So that's, I believe, going to give me 17.5. $17.50.